Welcome. So this question says a force of 2i plus 3j minus 4k newtons acts at the end of a lever whose length vector is given by 3i minus 2j plus 1k meters. And the first part is determine the vector torque created by this system. So let's visualize it first of all. So this would be my turning axis. And where's my lever arm? My lever arm is here. So this would be 3i minus 2j plus 1k meters. And then schematically I can imagine a force here, and that will be 2i plus 3j minus 4k newtons. And so I'd like to find the vector torque. I can tell you now that if the let's write down the first thing. The first thing is that the vector torque is equal to r crossed with vector f. So that's something I have to memorize, and the order matters. So r cross f, and I can tell you that if the displacement is in that direction and the force is in that direction, then the vector torque would be pointing up out of the page through this axis, and that's using basically a right-hand rule. So this is a vector torque. It might not seem like it should be a vector, but it is a vector torque, and it is 90 degrees to the plane containing the displacement vector and also the force vector. Okay, so how do I do it? And basically I use my cross product methodology, and the first thing I do is I have to put down my first vector. It's r cross f, not f cross r. So I look in my question until I find my r, and my r is there. So I need to put that down first. So that would be plus 3 minus 2 plus 1. That's that guy. And then I have to put underneath it my f vector. My f vector is this plus 2 plus 3 minus 4. Okay. So now I need to be able to do my cross product, and I'm going to work it out as we go. So I cover over the I, and my first term would be plus, and that would be positive 8 minus positive 3. So that would be 8 minus 3. I. Let me double check that. Positive 8 minus positive 3. So I'm happy with that. And then to find my j, I cover over my j. Now, I've got to remember this is a negative term, and that would be minus 12 minus positive 2. So that would be minus 12 minus 2 is minus 14. But there's a, well, minus 14 minus 12 minus 2. J. And let me just double check on that. So it's going to be minus 12 minus 2. Good. And then let's get rid of that. And then let's do our third term. And for my third term, it's a positive term, and I'm going to have plus 9 minus 4. Plus 9 plus 4. Okay. So this is going to be 8 minus 3 is plus 5i. Minus 12 minus 2 is minus 14. That negative in front makes it plus 14. 14j. And then 9 plus 4 is 13 plus 13k. So I would say that my vector torque, which equals vector r crossed with vector f, is equal to plus 5i plus 14j plus 13k, and it's a torque, so it must be in Newton meters. There's the first part. And then the second part says, what is the magnitude of this torque? And the easiest way to get the magnitude out of this is to simply use Pythagoras in 3 dimensions. So if you like, the magnitude of torque is equal to the is equal to plus 5 squared added to plus 14 squared added to plus 13 squared, and I want the square root of that, so that's to the half. So my magnitude of torque is going to equal, let's get my feeling, I'm going to need my calculator, and I'm at an age where I need my glasses when I need my calculator, so that's going to be 5 squared is 25, that's going to be 25 added to 14 squared is going to equal 196, 196 added to, and 13 squared is equal to 169, 169, and I want to take the square root of all of that. So this is going to equal 25 plus 196 plus 169 equals 390, which equals 390 square root of that, which equals second square root, second answer equals 19.75, which equals 19.75 Newton meters. So my torque magnitude is equal to 19.75 Newton meters. And I haven't got space, but if I wanted the direction, I would take that vector torque and divide it by that magnitude to get a unit vector which points in the same direction as that vector. So there we have it.